Hello, welcome back. So I was asked by one of the viewers to do something on the same tune of voltage drops. I have a little bit more in-depth one I'll do, but I'm going to try to release this just real quick, just to be able to understand the simple concept of a voltage drop. So I will say that it was many years in the trades before I understood this, so don't feel bad if anyone who doesn't. It will be worth your time to sit here for 2 minutes, 3 minutes, and see what's going on. So right now we have a light. We have the key off, so we'll turn the key on. We have a light here that does in fact turn on. It is just very dim, and when I do an applied voltage check, I only have 2.7 volts at the lamp. So just turn this off, talk for a second, and then we'll just test it again further up the harness. I'll show you how to troubleshoot this. So we know that if we take the load off of the circuit, we can see what's available within the wiring and the control element of that wiring to be able to deliver the power that we're looking for, that 12 volts applied that we need, because it's a 12 volt component. Keep in mind, some are 24 volt. There's some models that are 24 and 12. Make sure you understand the system you're working on. Okay, so now we're looking at that same power and ground that's available, but now the load's out of the way. We've taken the load and we removed it. We have that same 12.4. When we use this load probe, Bees Knees 2000, and push the button, it uses a 25 ohm resistor, and it applies a 1/2 amp load to that same circuitry. And right now we have 8.78. So we definitely have a problem with either our power or our ground to the light. How do we determine which side it is? So what I've done here is I've installed a jumper, and that jumper is to the power side of the battery. So it's a 50-50 chance, right? Just I have to split the circuit though. So instead of me testing up there, I'm going to test back here now. All right, so I've got the power from the 12 volts is coming now from the battery, and the other ground is still being provided by the board. So the only thing I've removed from this harness as far as seeing whether or not what side of it is the power side. So now when I push this button, I only lose 1/4 volt. So what do I know? I know that it was the power side because, well, I'll show you what will happen if I use the ground. So let's say I connect this back up, put this up here, and I use my multimeter lead on the ground side of the battery. I'm going to shift this over to the ground side, and I'm verifying that the ground on the board is going to do the trick. So if I hit this again, it goes all the way down to 874. So that even with a supplementary ground, it's not the ground's fault. If it was the ground, I just replaced it with another. I'm using this side, the power side, and it is not able to sustain the load. So how do we troubleshoot that? It's quite simple. We just come back from this point. We'll keep our multimeter lead on the ground because we know it's not our ground. Let's connect that here, and we'll walk our way through up the harness. So right here, again, 12 volts, apply our load pro, still drops. Dang. Okay, let's go further up the harness. Let's go to the top side right here. We'll call that yeah, it's still the same. Let's go below that. Okay, 12, now we're talking. So when I push that down, the only thing I see now is 12.26. That tells me that between this point and this point, my voltage is dropping. That's all a voltage drop test is. Now, can I do it without the load pro? Yes. You just connect up your load, turn your light on, and work your way back until you find out where that 12 turns to whatever that now the 6 or however many volts is being applied to the load. Keep in mind, this voltage drop doesn't really talk as much about the ECM and how it uses sensors to drop to pick up a signal voltage by a voltage drop across say a resistive circuit, something like a thermistor like we talked about the other day. So if I know that, I have to understand that maybe poking holes inside of something, adding a bit more resistance than what it's intended or engineered for, can actually cause a lot of damage and lead a lot of people chasing their tails. That's why we don't do it as a practice. So I will say that there is an acceptable drop across the load. It's 1/10 volt. So if I look at, not a load, off of a contact, let's say that I have a metal switch, like an old binary switch, on off. The contacts inside of there can wear. How do I test it? I should see 1/10 volt from the voltage going in to the voltage going out. I should have applied voltage all the way into the circuit and consumed on the ground side. So I should see 12 volts here, all the way up, like we saw, all the way up to the load itself. So the other thing I would say is that they build circuits to have a certain amount of resistance built into them and to be able to handle a certain amount of power. So I wouldn't really overthink whether or not it was built incorrectly as part of it. And then remember that you can't add resistance to a circuit like a 12 volt circuit and get full 12 volts, but you can still get the light on. So that's why we don't use lights to see if a circuit's live. It's subjective. It turned on at 2.5 volts, and that's nowhere near what I need. So I can't look at a light. Now, it was dim, yes, but what's dim and what's bright? Depends. I've seen a lot of dim and bright people. So that's my 2 cents about this. The only other thing I would say is that remember that in Ohm's law, I'm not going to get into the equation, but there is a way to look at and analyze certain parts of the circuit and be able to do the math to find out the other parts that you don't know. And that's about as far as I would go with Ohm's law, as far as what we're doing right now, building up to everyone becoming a whole lot more proficient with working with wires. Okay, hope you guys have a good day, man, and thank you for every like you've given.